అందరికీ నమస్కారములు. గురుభ్యో నమః. శ్రీ మహాగణాధిపతయే నమః. Today is a special day for all of us that we are going to have a special class on Vedic mathematics. A lot of people have doubts on the basics of Vedic mathematics. So Gautham ji is kind enough to and agreed to give an extra class for us. And we will start the session with Vande Mataram and Prarthana. Let us request Challa Chittibabu Garu to chant Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam.
Unmute చేసుకుంటారా?
నేను అన్మ్యూట్ లో ఉన్నానండి.
అన్మ్యూట్ లోనే ఉన్నారే.
రావట్లేదా?
మీరు అన్మ్యూట్ ఓన్లీ.
వినిపిస్తుంది సార్. వినిపిస్తుంది.
వందే మాతరం, వందే మాతరం, సుజలాం సుఫలాం, మలయజ శీతలాం, సస్యశ్యామలాం మాతరం, వందే మాతరం. శుభ్రజ్యోత్స్నా పులకితయామినీ, పుల్లకుసుమితా ద్రుమదళ శోభినీ, సుహాసినీ సుమధుర భాషిణీ, సుఖదాం వరదాం మాతరం, వందే మాతరం, వందే మాతరం.
ధన్యవాదములండి. అనంతన్ గారు, కెన్ యూ చాంట్ ప్రార్థన ప్లీజ్?
హరి ఓం. ఏక నిమిష ధ్యానం. Let us sit erect. Close the eyes. Relax the body. Total concentration on breath. My mind goes elsewhere. I bring it back and make it to watch the breath. త్రివారం ఓంకారం. गणानान्त्वा गणपतिगुं हवामहे कविं कवीनामुपमश्रवस्तमं, ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनशृण्वन्नोतिभिः सीदसादनं, महागणपतये नमः. प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती, धीनामवित्र्यवतु. वाग्देव्यै नमः. Gurureva gatir gurumeva bhaje gurunaiva sahasmi namo gurave. Na guroh paramam shishurasmi guroho matirasti gurau mama pahi guru. Jnananandamayan devam nirmalaspatikakritim adharam sarvavidyana hayagrivam shruti shruti purananamalayam karunalayam namami bhagavat pada shankaram lokashankaram shankaram shankaracharyam keshavam badarayanam Sutra Bhashya Krutau Vande Bhagavantau Punah Punaha Ishvaro Gururatmeti Murti Bheda Vibhagine Yomavat Vyapta Dehaya Dakshina Murtaye Namaha Om Sahana Vavatu Sahanau Bhunaktu Sahaviryam Karavavahai Tejasvi Navadhitamastu ma vidvishavahai. Om Shanti Shanti Shanti. Harihi Om. Namaskara.
ధన్యవాదములండి అనంతన్ గారు. Now let us request Gautham ji to start the webinar, please.
Namaskar. Swami Namaskar. Yesterday, we were here. We were discussing near about that. I was telling what is the procedure, that algebraic logic behind such this Vedic online method. And we have seen earlier that in case suppose we know n by 19, anything 1 to 18 divided by 19. So in conventional method, we have to do very big calculation or 18 steps each, and that to repeat that thing 18 times, taking 1 to 18 different digits. Whereas in this Vedic online method, if we know sequence of these, for example, in this case, 1 by 19 sequence is given fully with all the both quotient and remainders. Those quotient are the part of result, and remainders are taken as a indication. So where you start with the for any any other fraction, like here you see that 7 quotient and 1 remainder. You see, so that means it is 70. If we given the task of evaluating 17 by 19, we will start after that 0.8947 and so on. The same thing we could have done also right to left, starting from 17 means that 7 into 2 plus 1 is 15, 5 into 2 plus 1 is 11, and 1 into 2 plus 1 is 3, 3 into 2 is 6, and so on. Again, it comes back opposite direction. So in any direction, if the both the quotient and remainder information is preserved, you can do in any way. While starting point will be the same thing when you go to right to left, and starting point will be the next one. I mean, in this case, it is 8 with remainder 1. Starting point will be 8. The next one of that, suppose I will be making 17. Next one for left to right calculation. Is it clear? Clear to everybody? So this is about n by 19. Similarly, we do n by 1 by 29 we did, and from that we can do similarly. It is already divide by 3. in this case, because this 2 plus 1 is 3, and we start dividing by 3. Similarly, I told that the n by 19, n by 29, that you can make anything. Suppose you want to make, want to make 15 by 29. What do you start? This one. After this, 5.51724 and so on. And in case of 5 by 17, 5 by 29, it will be 0.17241 and so on. So n by 29 formula was there. Some guess for this one. Give that. Now here example is given for 59. So it is very big. So I just pasted the Excel sheet. I have an Excel sheet which does all this. Very easy formula is there. And anybody is interested in Excel, I can also do this thing. And it is about dividing by 6. Now, what is the algebraic background of that? It is like this. It is 1 minus x to the power minus 1. Because if we express 1 by 10 into n minus 1, that means 19, 29, 39, etc., or 10 times some digit and minus 1 and inverse of that. Okay. So suppose we take n is equal to 2. So 10 into 2 is 20, minus 1 is 19, 1 by 19. So 1 by 19, how it will be doing? It will be 1 by 20 into this 1 by 20 to the power minus 1. So actually, basically, thing is like that. Basically, suppose n is equal to 2, I told, in case of 19. So it is 1 by 19 is actually becoming 1 by 20. Basically, we told that to divide by 2. But actually, in the background, we are dividing by 20. Because when you are shifting towards the next digit, it comes dividing by, equivalent to dividing by 20. So it is ultimately is going like that. It is the last step actually. 1 by 20 into 1 plus 1 by 20 into 1 plus 1 by 20 and so on, like that. Is it clear? Always you are by 20 and something is remaining. It is matching plus something is remaining, and that is getting added every time, and that we are digit after digit we are getting. Now other kind of denominators. So far we have used only denominator with 9, ending with 9. But what about ending in 1, 3, and 7? This also will, as I told earlier, that 1, 3, 7 also will give this recurring decimal. So how to evaluate this? Multiply both numerator and denominator by 9, 3, and 7 respectively to get the denominator ending in 9. That is the thing. So 1 by 7 becomes 7 by 49. We start with 7 and divide by 5. This 49 means dividing by 5. So 7 divided by 5 gives, you can see it. Should I do it on white screen? One by 7. What should I do?
Multiplying numerator and denominator by 7. 7 by 49.
Suppose I do another one. Let us see 3 by 7. What should I do?
$21 by 40.
21 by 49. Now, how will you start? So 21, we should divide by what? I'm following a different symbol for division. We'll divide by what?
50.
5.
So So I write here this 3 by 7 is equal to 0 point. Now this 21 divided by 5 is how much?
4
4,
and 1.
1.
4 and 1.
Reminder.
So remainder 1.
And again, then after this
2. Remainder 4.
2 remainder 4. Now
8. Remainder 2. 5. Remainder 2. No, sorry.
5. Reminder 0.
Yes, 5 remainder. 7. Remainder 0. Uh, 1 remainder 2. 4 remainder 1.
so we come back to again 4 remainder 1.
Yes.
That means this. Here you see from this, can you guess for others? Like say, I want 6 by 7. Are you
42 by 40. 42 by 40.
Exactly.
1,
So
142. 142,857.
no. It actually means there is 42, no? 42 by 49. So where you see 49, 42? Yeah, isn't it? So it should be
85714.
exactly.
Yes,
8,
yes, yes.
5,
857,142.
7, 1, 4.
42.
So without knowing this thing, there are a lot of people you played with these numbers, this 142857. People do like this because people you multiply it by 2, what happens? Multiply by 3, what happens? It's called circular. People are get fascinated with these circular numbers of this kind. If you multiply by 1, 2, 3, and 4, it gets circulates actually. So this is the circulation, the logic or the mystery behind the circulation is this basically. We do not, people do not play with that 18 digits, 1 by 19 or 2 by 19, etc. But this 7 is very popular for this kind of, we call circular numbers, people call them. So this is the mystery of this. But actually, in case of 7, suppose you started multiplied by 5 with these particular numbers, all the multiplication of 7, like 14, 7, 14, 20, 21, 28, 35, 42, etc. But any other number, if you start multiply, dividing by 5 this way, it will be very big circle, cycle of 42 digits. Something, anything other than these numbers, something by n by 49 normally will give all other digits which are a cycle of 42 total. And 42 and this 6 becomes 48. So like we got for say 18 and so on. 2 cycles, basically 2 cycles of unequal length. And similarly, 1 by 13 becomes 3 by 39. And divide by 3, similarly you can do, but here it also gives 2 cycles. Okay. You try sometimes, you will get 2 cycles. So like 1 by 17, as I told, is 7 by 119. Should I try this one? Anybody will try this about 13? wants to try? See, in Vedic mathematics, in the second level course, I insist that you try to teach somebody, like say students of class 5, 6, 7, 8, and so whoever is interested. You start teaching. In that process, all these procedures you will it will be very strong in you also. Maybe I'll come back and if there is some questions, you can do that. 3 by 4 is this one. 3 by 1 by 13 is 3 by 39. Here is another consideration, which is a little difficult this way, looking difficult, but not actually. This is about 1 by 21, 1 by 31, and 1 by 41, etc. And we have to multiply both numerator and denominator by 9. Very big number. Compared to that, we'll produce also very big number. 1 by 21 becomes 9 by 189. And the digit divisor becomes 18 plus 1, which is 19. Similarly, for 1 by 31, it becomes 9 by 279, which is digit divisor become 28. Okay, this 28. And for 1 by 41, it becomes 9 by 369, and the digit divisor is 37. Therefore, Vedic one-line methods needs a change. What is that change? Instead of considering this 1 minus x to the power minus 1, you consider 1 plus x to the power minus 1. Because it is of the category of 10 into n plus 1. For example, n is equal to 2 if you take 10 into 2 plus 1, 21. So it is under this category. So 1 by 10n plus 1 is this one. Again, by 1 by 20, 1 plus always this thing. Earlier we had 1 plus this thing to the power minus 1. Earlier we had 1 minus this thing to the power minus 1. And as a result, what is happening? It is happening this 1 by 20. I'll elaborate in this. 1 by 21, for example, say 1 by 21 is equal to 1 by 20 here, ultimately after this calculation, 1 by 20 into 1 minus 1 by 20 into 1 minus 1 by 20 and so on. So how it happens? The procedure becomes like that. To start with, it will be a little difficult. I will tell you about 1 by 41. This 14 by 41. 14 by 41 is an example. You do not get anything minus. If something minus is there, there is another way of handling. So actually, procedure is like this. See, 14 by 41. So 14 you are dividing by 4. In this case, not plus 1. This is only this much. This 4 has to be there. Earlier, it was in case of 39, you used 3 plus 1, 4. Here it is already above. So it is 14 divided by 4. So if I 14 divided by 4, our 3 becomes the quotient and 2 becomes remainder. Now instead of 20 plus 3, 23, you do 20 minus 3, which is 17. And 17 we divided by 4, 4 quotient and 1 remainder. Now, instead of making it 14, we take 10, instead of 10 plus 4, 14, we do 10 minus 4, which is 6. Is it very complicated? Please react. But you see, so easily it is doing, but it is a little, requires little practice. And again, 6 divided by 4 is 1 quotient and 2 remainder. So we are not working with 14, but working with 6. So 1 quotient and 2 remainder. Now 20 plus 1, 21, instead of 20 minus 1. This you consider as a vinculum. All the above ones you are considered as vinculum because there is a minus symbol here. In the expression, there is a minus symbol. This minus always in every step is making the rest of the thing as vinculum compared to that. So as if it is 2 and minus 1, like this. Like this.
Sir, what is written in the brackets?
Oh,
14
bracket you have
divided by
written
4.
that. Bracket I have written that it is 1 and 4 vinculum becomes 0.6. 1, 2 and 3 vinculum becomes 17. 2 and 1 vinculum becomes 19. And with 19 we have to work. This will be the thing we will work with, not this one. This one, of course, but with vinculum. After making it vinculum, it becomes like this. So 19 divided by 4, 4 quotient and 3 remainder. Is it 4 into 4 plus 3 is 19?
Yes.
Now, instead of that, you immediately make it vinculum. So that means 30 minus 4. So it is 26. We work with 26. Then it becomes again 6 as a 26, 6 as a quotient and 2 as a remainder. Again, you make it vinculum. Because there is a minus there in the expression. And 2 vinculum 6 becomes 14 again. Then we started with 14. So we put a dot here and dot here. So it becomes ultimately 0.34, 0.34146. Repeat. Also. 0.34146. 34146. Clear? Should we do it on what screen? The same one. Okay.
Let one of the students try on.
14 by 41. We start divide 14 by 4, not 5. But not anything else, because this 41 is not ending in 9, it's ending in 1. So you have to do that one also. Whatever before 1 it is coming, you have to divide by that. You tell me what should I do? 14 divided by 4. So my 14 by 41 becomes 0.3.
3.
14 divided by 4. What is
3
quotient and remainder?
3 quotient, 2 remainder.
3 quotient,
2 remain.
2 remainder. Okay. Then what is the step?
5 quotient, 3 remainder.
Remainder 0.
You also 14 divided by 4. I wanted to show how it makes difference. 14 by 39. 3 and 2. 3 and 2 it becomes. Then 23, so 5 and
5,
5 and 3, isn't it?
3 remainder.
3 remainder,
Yes.
like this one. But here, it will not be that. It will be vinculum. That means it is actually how much? 2 and 3 vinculum becomes
17.
17.
17.
Now 17 divided by 4.
Yeah, people have to say, he's waiting.
4-1, sir.
4-1.
4 and 1. Okay.
Keep saying the next, and the next. Keep saying.
Next to you,
6
0-6 is the vinculum.
next to you, put a vinculum.
1-1, 2.
0-6.
0-6 is the vinculum.
It is 1,
1-2. 2.
1, 2. It is 1, 2.
The 9 becomes 9. 9
No,
means
you need
2,
to
1.
make it
2-1.
Vinculum.
2-1.
19.
2-1.
19.
19 vinculum.
Sir, here in this previous one, you have taken 0-6, no? Then it should be 0-9 only, no?
1, 9. 2 and
How can it be? See,
1
previous
vinculum.
case, it is
It was
0-6
1
you
and
have
14.
taken.
2 and 1 vinculum becomes 19, no?
Okay, okay. Okay, sir.
Then 19 divided by 4.
4. Vinculum 3.
No.
4, remainder 3.
Or in 4 remainder 3. Now make it 4,
26.
make it vinculum.
26 vinculum.
It becomes 26.
6.
26. So then again 26 you divide by 4. What happens?
6. 6 remainder 2.
Then I
14.
make it. Then becomes
Then again
14.
14.
We started with 14.
Yeah, 14.
Now there will be 5 digits. In case of this one, because 99999, these 5 numbers of 9 is a multiple of 41. So therefore we will get 5 digits in case of 41. Something by 41. So ultimately what happens? 0 point, what is the result? 0.3. Now you forget about we have spoiled it by vinculum, but no vinculum. 3, 4, 1, 4, 6. Isn't it? Please tell any other fraction. Three, 4, 1, 4, 6, 3, 4, 1, 4, 6. So now any other thing you want to try?
Hope all are following and understanding. If you have a doubt,
But
this is
here
a
actually
revision class.
those things cannot be done. I
Yeah.
still could not discover how from 14 by 41 by this expression you can guess others, because it becomes too complicated. Becomes maybe 19 can be done. I think from this can we guess about 19? 19 by 41. Let us see 19 by 41. Whether the same formula works. 19 by 41. 0.46341. Yes, here also it works. Very interesting. See, I'll erase. See, 14 by 41 was 0.34146, isn't it? What about 19 by 41? 19 by 41 will be 0.46341. 6 by 41 will be 0.146 3, 4.
Excuse me, sir.
Huh?
1 minute.
You
Excuse me.
have to consider these ones, not what is outside bracket. The bracketed things, from this one, you can guess about bracketed things only.
So, excuse me, sir.
Huh?
So 14 by 4, you get 3, remainder 2.
Huh?
So what is this 17, sir? How do you get it?
Yeah. I told you earlier. You consider it
I
as
could not hear properly, sir.
you consider now because there is a minus in the expression.
Yes.
There is a minus instead of this plus. Earlier we had a plus, no?
Yeah.
You see there is plus already. So we remainder this remainder we multiplied by 10 and added with that quotient. Should be because of this. These steps are those adding. Here we have to subtract. So this becomes a vinculum. Here this is minus always. Instead of plus, we have minus. So therefore, what happens? Now it becomes vinculum. So 22 and 3 vinculum is the 20 minus 3, which is 17.
Oh. The next step, next second one.
This is 4 and 1. 17 is divided by 4 is 4 and 1. And again, 4 becomes vinculum. So it becomes 6. This way. Now, what I was telling that you can also have cycle of this like this. 14 and 30, 34 and so on.
This, how do you get this 6, sir?
6 is 1, 4 vinculum. 10 minus 4 is 6. 1 and 4. This 1, 4 vinculum.
Okay, sir. Follow.
Equal to 6.
Thank you.
This is the vinculum, no?
Yes.
Now, a challenge comes sometimes. Like what I will tell. You do for, say, 1 by 20. Let us do 1 by 21. It will be a challenge. First, I will describe here. Oh no, there is, yeah. See something by 21, say 11 by 21, let's. This gives 11 divided by 2. This equal to 0. Tell me.
5. 5. Remainder 1.
Remainder 1. Now,
Vinculum 5. 5. 0, 5 will be there.
It will be 0, 5. 0, 5. Now this divided by 2.
4, 1, 2, 2, 2, 1. 2 quotient, 1 remainder. 0, 8. Four, 0. Here, the catch. 0, 4.
Now tell me.
It's a catch. -4 only.
Minus
Minus
6.
4 only. And minus 4 when divided by 2. What happens?
-2, 0.
Minus 2. So this becomes oh no, I jumped the step. This is actually minus 4.
Minus
Bracket I'm writing
minus
now.
2, 0.
You should be writing minus 4. Okay. Like this one, I was doing always this vinculum writing minus 4. Now, when we act on this, it becomes minus 2. We write here 2 vinculum. Here it becomes 2 vinculum, but in the bracket, what happens? This gets reversed. So 2. When you divide it by 2, it becomes
2 is
1
1
and
remainder 0.
0.
Minus 1 remainder 0.
Minus 1 remainder 0. Minus 1.
Yes.
And here it becomes again, what happens? Here
0 remainder 1.
1 and remainder. So ultimately,
Sir, this last step, can you please explain on minus 1, the vinculum 1 by 0, remainder there.
which one?
Last step, sir, before this. Minus 1, remainder 0 from there.
This one.
Yeah.
This actually
one.
becomes ultimately it will come like that. 0.52 4. Okay. And 1 came here. This one. And 1. This again comes. See, this minus 1 came here, no? And result was 1 and this thing.
So minus 1.
And
minus
this
recurring
1 and 0. This 1 and no, mind it. Now this challenge comes actually. Minus 1. Minus 1 divided by 2. What will be the quotient and remainder? Here it is minus 1. No, you got minus 1. Minus 1 divided by 2. How much it is? It is not 0.
Not
it is
0.
Minus 1. Minus 1. Here it is like this. Minus 1 and 1. You here you always remember that the remainder is never negative. Remainder is always positive. So when you divide minus 1 by 2, my quotient becomes minus 1. That will give me minus 2. And then we are adding this. The remainder is always added, always positive. So this is minus 1, isn't it? I mean, minus 1 into 2 plus 1 is equal to minus 1. So when you divide minus 1 by 2, if my quotient becomes -1 and remainder 1. So it is actually this one, and then we get the result of this becomes next one 0 and sorry, it is this 1. I made it mistake that time. 1 and -1, and I will make it vinculum of that thing to make it positive. So it actually gives to 11 again. This gives to 11, and we started with 11. So therefore, this result is this one. My result becomes, see, this is 5, this is 2, this is 4, but this was already vinculum. So we made it vinculum, and again double vinculum it is because it's positive. So these two vinculum actually is the result. And again this after that this one, because after when we are making the vinculum to make it to understand the bracketed one, and then again this was automatically -1. So I put in going to get this one to get it. Now I have to get it -1. The result was -1. The results were always this 5 to 4 to vinculum. Now if we clear the vinculum, it will be actually 5 to, what is that? 4 and vinculum 2? 4 and vinculum 2 is
3, 8.
3, 8. And
Hope others are following it.
1 and vinculum 1 is 0, 9. So this is actually the result. You verify with calculator. So actually this becomes complicated, a little complicated, but with practice it can do it. We would always see that. Should I do another? I start with, see, here it is exact. For denominators of the form A1, we simply divide by A. Let us take the case of 1 by 21. Here the digit divisor will be 21 minus 1 by 10, that is 2. We proceed as follows. 1 divided by 2, quotient 0, remainder 1. Considering the binomial expression, we have to do 10R minus Q, 10 into 10 times remainder minus Q in this case, instead of 10R plus Q earlier, means that for ending in 9. Now 10 into 1 minus 0 is 10, and 10 divided by 2 is 5 and with 0. 5 and 0. Now Q is 5 and remainder 0. Next, 0 into 10 minus 5 is minus 5. With minus 5 divided by 2 is Q is equal to minus 3 and R is equal to 1, because minus 3 into 2 plus 1 is minus 5. Here, quotient can be negative, but not the remainder. Remainder can never be negative. Then, so far the result is shows this. We got earlier this 0, Q is equal to 0. What is my?
Excuse me, Gautam ji.
Huh?
Here, when you said minus 5 divided by 2, quotient is minus 3. I think people have to understand why this minus 3 has come. Because you go on the number line, you have to take the 6.
Number line.
Yeah.
Yes.
That I think people have to
Understand.
Right.
This is 0. This is minus 1. Okay. Minus 2, minus 3, minus 4, minus 5. Minus 6. So this is minus 1, minus 2. Can you see this in the bottom line, everybody?
Yes, sir.
So basically, we have to divide this minus 6 first. So -6 only get is -3. And -5 I have to put -5 I cannot divide. See, this is just the block. This is one block, 0 to -2, then another block -2 to -4, then another block -4 to -6. These blocks we have to divide into one block. So we get at this -6. -6 divided by 2 is -3. But we are not dividing by dividing -6, but dividing by -5. So this remainder, this is the remainder. This to this becomes my remainder. Is it clear? Or I've shown here that -3 plus -3 into 2 plus 1 is -5. So therefore, -3 is my quotient and 1 is the remainder. That, as I told, remainder can never be negative. This is the idea. Now, so therefore, what happens? I am erasing this one. So Q is equal to 0 I got initially. Now I got 10 or minus Q, no problem here because it was Q was 0 in any case. So whether you subtract or add, it didn't find any difference. It got 10. So then you got this. So this one. This is quotient 5 and 0 remainder. I put it shortly, like not like this. I mean, sorry. Q is equal to 5 and R is equal to 0. Next, this becomes -5. So this becomes Q is equal to -3 and R is equal to 1. So we got 0, 5, 3 coulomb. And now this 10 into 1 minus of -3 becomes 13. Because of this 3 and remainder 1, -3 quotient and remainder 1 will become 13. It becomes positive now. Because it is 10 and -3 again, shows it opposite. So minus this 13. And 13 divided by 2 is Q is equal to 6. And so R is equal to 1. So it gives actually 0.05 coulomb 3 and 6. Now 10 minus 6 is 4. So 4 divided by 2 is Q is equal to 2, R is equal to 0. So this gives it 0.5 coulomb 3, 6, 2. Now again we got 10 into this thing, 10 into 2 minus 2. So -2 because this remainder was 0 in this case. -2. -2 divided by 2, Q is equal to -1 and reality is 0. Reality is this 0.5, 3 coulomb, 6 to 1 coulomb. Next dividend is 10 into this thing -1 is 1. It comes back to here and therefore it becomes 1 by 29 becomes 0.05, 3 coulomb, 6 to coulomb. If you clear that, it becomes 0.047, 47619. This is I shown repeat. Clearing the coulomb, we got this one.
But sir, in this case, is it not more complicated the conventional method?
Conventional method actually.
You have to remember so much of.
Yeah, algebraic expressions you have to remember.
But actually, this concept is required. Concept should be clear.
I know, but what is the motivation to do it like this compared to the conventional method?
Motivation is that, as I told, that if we do normal way, you have to divide by 19, divided by 28, divided by 37. See, for
this is also looking complicated only.
41.
The purpose of this learning, sir, we are not using it, as on today.
Actually, this is the, for your.
When the era of calculators and computers, so where will they place for Vedic mathematics?
I told that one yesterday or day before. That actually this Urdhva Trijagabhyam.
So it is only mind exercise will
No,
be
no,
more
not mind
than
exercise. Not mind exercise. I tell you this I told you the Urdhva Trijagabhyam I told. While considering this Urdhva Trijagabhyam, earlier this one, this type procedure. This procedure actually, when it is translated into the circuit of the computer or any processor, I mean mobile computer, any electronic device, this actually gives more efficient and consumes less power than the conventional mathematics.
But
So-
has anybody implemented in computer this one?
Yeah. It is happening. And you have shown, and the chips are coming with these things. While multiplication is very important. So in whatever sort of displays you're going on your my laptop or mobile and so on, that requires always a lot of calculation. If each cycle of the calculation saves some power, it will be a very big power saving. So basic mathematics principles are being implemented. So calculator is, you mentioned about calculator. I tell that calculator means that those mobile devices, those becomes more efficient using the Vedic. So moreover, see, in this process you start learning more, because this how this can be done, and earlier you didn't know that if negative number is divided by 2, for example, what is the quotient and what is the remainder. But you learn that it is this procedure is there and so on. Anyway, this is the one negative method is one of the alternate ways, like this one for 31 and 51 and so on. Now we come to 1/7. For 7 we have choice. See, I now suppose I have given the task of 8/17. We can express it as 56/129 or 24/51, whichever you like. Here is the procedure of dividing 56 by 12, and this one you get 56 divided by 12. 4 is my quotient and 8 is remainder. 84. 84 divided by 12, 7. 7 divided by 12, 0 and 7 remainder. 70. 70 is 5 into 12 plus 10. So 5 my quotient and 10 is remainder. And then it becomes 105. 8 is my quotient and 9 is remainder. 98. This way. What is it? You handle with big numbers, always dividing by 12. And whereas it is here, it divided by 5. 24 you divide by 5. So 24 is 4 and 4. 4 and 4 vinculam becomes 40 minus 4 is 36. 36, 7. 7 is the result. 7, 36 by 5. 7 is quotient and 1 becomes remainder. And instead of 17, it becomes 17 becomes 3. 3. For the 0 quotient and 1, 3 remainder. So this way, same proceed 47063470. You see only that this 58 is 58 would got 6 and minus 2. 6 minus 2 is 58 and 3 minus 1. We only get 2 such things. But you told about complications, the only 2 places we get complications. Otherwise, it is going on very nicely. Okay, now I had given the exercise. Now, periodicity of the recurring decimals, how it comes? It actually, periodicity becomes the being factor of so many of 9s. It's called repeat 9 numbers. 101 is a factor of 9999. So if I start when something by 101, we will have 4 repetition 4. 41 I will have already started. We have already tried ourselves, and there was this 5 digits of 9. 5 digits. 271 also will have like that. 123 in case actually it is actually 3 times of this one, so it will have same thing actually. 239 will have repetition 7. Earlier we have seen that for 3 it is 1 repetition 1, 11 is 2, 37 and 27 repetition 3. These are more common actually. Repetition 6 is more common. 7, 13, 29, 31. So many things actually repeats in 6. 18. This 19 actually I have seen earlier. This 18 digits. 18. Okay. I wanted to show you something. Suppose I divide something when 13. We divide by 4. Okay. What happens? What is the quotient and remainder?
People have to say the teacher is waiting for your answer, response. 4 and
Sir.
1.
Three is the quotient, 1 is remainder.
3 and 1.
And you hit 3 and 1. Why it is happening? Can anybody tell? Let us see what is your concept. It happens with 26 also. What is that? 26?
5 is a quotient and sorry.
Yeah, 5 quotient
6
and 1
is
remainder.
6 is quotient, 2 is remainder.
Then again,
Again 6.
same thing repeats, no?
6 repeats, 2 is remainder.
Why it is happening? Can anybody tell? It's very mysterious, no? I innocently started dividing anything. I can do divide anything, it will not happen. 11 we divide by 4. It gives
13
actually. It
and
gives
20.
2. Here we get
2, 3.
and then 32. It becomes 8. Huh? Do you listen to me? Actually, it gives some produces different. But why it is repeating here? Can anybody tell? Because actually dividing by 4 and doing this calculation means it actually the fraction denominator is 39. And what is 13 by 39?
1 by 3.
This is this I posed the question because to make you alert actually. So similarly, this is amount to 26 divided by 39.
2 by 3.
2 by
2 by 3. 2 by 3 is 0.6666, isn't it? And 1 by 3 is 0.3333. So this is the mystery behind these things. Sometimes we get this thing. And 1 by 13. 1 by 13 has 6 cycle. This 6 into and 6 cycle of 6 length. 6 into 6 is 6 into 6 is 36.
36.
And plus these two, which is 38. It completes this earlier for 19 we got a cycle of 18.
18.
For 29 we got cycle of 28.
20.
But what happens for something divided by 39? We get 6 cycle of 6 each and plus these two. Those two, it's completely separate type of object. And totally 30. Always we get like that. Always all these cycles, if we add, it will come to that d minus 1. That means that denominator minus 1. In case of 39, we have to get 38 somewhere. How we are getting 39? 38, that 6 cycle of 6 is plus this one cycle of 2. 1 cycle of 2. 1. So this is to have a concept clear about this one, how we are getting all these things. Now we come to divisibility. Now divisibility in general we are taught in schools Divisibility by 2 to the power n. It requires n digits to be divisible by 2 to the power n. That means, you know, odd and even some can you some vehicle sound is coming somewhere. Anyway. You can mute your mic, and whenever you want to speak later on, you can put it on. So now, numbers 2 and 5 are the factors of 10. So we have similar rules. Divisibility by 2 to the power n requires last n digits to be divisible by 2 to the power n. For example, this one is divisible by 2 because, so divisible by 4 because 56 is divisible by 4. Whereas it may not be divisible by 8 because 356 is not probably divisible by 6 and it's 8. It is divisible by 2 because the last one is divisible by 2. We know odd and even. Last one is odd. Last one is odd means not be divisible by 2, and last one even is the whole thing is even and divisible by 2. So, but the thing is that for any power of 2, it is the same number of digits. Similarly, for 5 to the power n, 5, 25, 125, etc. This particular number is divisible by 25 because the 75 is divisible by 25. Is this clear? Now, divisibility by a composite number demands divisibility by its factors. If 42 is divisible by 6 because it is 42 is divisible by 2 as well as divisible by 3. 135 is divisible by 15 because divisible by 3 as well as 5. Divisibility by numbers ending with 1, 3, 7, and 9 has general method of osculation, which gets a trivial form in case of 3, 9, and 11. We are taught that for 3, 9, and 11, what is the procedure? Anybody can remember for 3, 9, and 11? For 3, for example, what is the procedure? Divisibility of 3 and 9 is the same. Number is divisible by 9 if sum of all its digits is divisible by 9. And for example, it is 27. The whole thing is divisible by 9 because sum of this is 27. You add up all these things to 27 and divisible by 9. So the whole thing is divisible by 9. But in case of 11, a number is divisible by 11 if the difference of the sums of alternate digits, even an odd position, is 0 or divisible by 11. For example, the number, this one, is divisible by 11 because 9 plus 4 alternate. 9, 4, 7 this side, and 3, 5, and 1 this side. Alternate digits are you sum them and you make the minus, and the whole thing is divisible by 11. So therefore, this thing is divisible by 11. Now this exercise was given. Now for others, what will happens? A 2 or more digit integer n can be expressed in the form this one. This I have given an example. You can see that algebra you can follow later. You can follow. This is called osculation. Osculation is Vedic method to create a smaller integer like this. We take the unit number. Unit number we multiply by the suitable digit, suitable number. Unit we multiply by number and add with that add with the rest of the numbers, and they get a smaller number. It is smaller than the whole thing. Earlier it was 10r plus u, not r plus mu. It is a more smaller number. I'll give you an example. I'll give, and that dividing that thing. So now we take an example. Let us test whether 343 is divisible by 7. So first we find the oscillator of 7. We find that 10 into 5 minus 1, that is 49, is divisible by 7. That the oscillator A is equal to 5. So we have to work with 5. You remember for 1 by 7 also we worked with 5 earlier. So it is something to do with that also. And 343 to 34 plus 3 into 5 is 49, which is divisible by 7. So 343 is divisible by 7.
Sir, here 10 into 5 minus 1. What is this, sir? How it has come and it is related here to find this m value? What is this formula? 10 into 5 minus 1.
For a digit ending in say 5, ending in 7. Okay, I tell you. For any number ending in 1, somebody take 31. Oscillator. Here, oscillator with me. It is already ending in 1. So my oscillator will be minus. Yeah. For 41, my oscillator will be minus 4 and so on. For ending in 3, suppose I get say 23. So 23 ending in 3, either you make it multiply with something to end it either 9, either 1 or 9. So 23 into 30 becomes 69. And 3 becomes 69. This is the lowest I can do. For 3, I have to multiply by 3. So that it becomes 69. So oscillator for 23 becomes this. This becomes this 70 minus 1. So this is actually 30 plus 1. Instead of plus 1, you get this oscillator become negative. Here you get plus 7 is the oscillator. Say, for example, another example, say 43. 43 into 3 is how much? 129. And 129 is 13 into 10 minus 1. So oscillator is plus 30, plus 13. In case of anything,
For 343, sir, for 343, you have said this oscillator.
which one?
343 number, 343 oscillator.
It will be very big. Consider smaller numbers now. After that, we'll see. 342 taken to multiply by 3. Suppose we get 19. You tell me what will be the oscillator for 19? It is 20 minus 1. So oscillator is plus 2. What you will see, in case, suppose it's 17. What is the oscillator? Can anybody tell? 17, what is the oscillator? This is not 17, this is 7. For 7, what is the oscillator? Because 7 into 7, for anything ending in 7, you have to either you can multiply by 7 to get this is 7 into 7, the oscillator become plus 5. Or we could have done 7, we could have done we multiplied by 3. So that becomes 21,
2.
and oscillator becomes minus 2. I'll come to that. So here I have this positive oscillator I have shown here, that you have to do like this 5, always do 5 multiplied by 5 and add this thing. For 13, let us first find the oscillator of 13. So you have seen that with 13 into 3, 39. So it ends in 9. So 10 into 4 minus 1 is divisible by 13. So M is equal to 4 for 13. So 11635, we have to do 1163 plus 5 into 4, 1183, 1183, 118 plus 3 into 4, 130. Again, this, and it's 13 plus 0 into 4 is 13. So it is divisible by 13. So this is 412 divided by 23. We find that 10 into 7 minus 1 is divisible by 23. We divided multiplied by 3, so it's 69. So we find that it is 10 into 7 minus 1. So oscillator of oscillator M is equal to 7 for 23. So 41285, 4128 plus 5 into 7, 4163, 416 plus 3 into 7 is 1. This one. Okay. Positive and negative and minimum oscillator. In case it is 10M plus 1. 10M plus 1 divided by D. So this one also is the same thing. For 7, we could have used minus 2 as I told. How it can be, an example I give. See, here is a table of oscillators. For 9 and 11, it is plus 1 and minus 1 respectively. For 3 also. For 19 and 21, they are plus 2 and minus 2. For 29 and 31, plus 2 and minus plus 3 and minus 3. Oscillator. Oscillator 3 and oscillator minus n, means minus 3. For 13, 39, oscillator is plus 4, and for 41 it is minus 4. For 7, 49 it is minus 5, plus 5, and for 51, 17 and 51 is minus 5. This way the whole chart is there. That's by factorizing these things. by the factorizing this 10n minus 1 and 10n plus 1, I've made this thing. Now, how to do about negative exclusion? Testing divisibility of 8-4 distinct by 7. We find that 10 into 2 plus 1, 21 is divided by 7. So negative oscillator of 7 is this minus. So we do the following. 842912, 84291 minus 2 into 2, 4. So 84287. See, always it was 6 digits, it came to 5 digits. And again 8428 minus 7 into 8, this becomes 4 digit. 4 digit, from 4 digit become this minus 4 is 3 digit. From that one, 83 minus 3 into 2, 77. 77 is divisible by 7. So therefore, all these things are divisible by 7. Note that for divisor ending in 1 or 7, we will have easier to use negative oscillator instead of positive oscillator. For example, in 21, this one is 20. Otherwise, for 21, it will be very big. Earlier, it has similarity of our the fraction, denominator. Earlier, it has some similarity with the recurring decimal. Those numbers. So not much time is there. Divisible by composite number. To test the divisibility by a composite number, we may test divisibility by its factors. For example, divisibility of by 92 and 93. To test whether this thing is divisible by 92, we find 92 is equal to 23 into 4. The number 2856 is divisible by 4, as last 2 digits are divisible by 4. So this is already passed. Now oscillator of 23 is 7. We do 8556, 855 plus 6 into 7, 897. From that 89 plus 7 into 7. So 89, it becomes 238. And 13 plus, this 13 plus 8 into 7 is 69, divisible by 69. So therefore, this also is divisible by 23, therefore by 90. There. Composite numbers. Whether this number is divisible by 93, we will find that 93 is 3 into 31. This is divisible by 3 because 8 plus 5 plus 5 plus 6 is 24, is divisible by 3. Now oscillator of 31 is minus 3. We do 8556, 855 into 6 into this 6 into minus 3. 37, 83 minus 7 into 62. And 62 is divisible by 61, 31. So therefore it is divisible by 93. Now for multiplex oscillator, there is the algebra again. For 10 to the power r. Sometimes what happens, like these numbers, 120, 199, 299, 399, all this. Could have taken oscillator as 20, 30, 40, etc. But instead of that, we take multiplex oscillator as 2, 3, 4, etc. They are called multiplex oscillator. But we have to group it accordingly. Let us check whether this big number is divisible by 299 or not. We see that second order oscillator is 3. Because it is 3 into, earlier we have did 10, but now it is 100. 3 into 100 minus 1, 299. So it's second order oscillator. This second, why second order? There are 2 numbers of zeros. Second order oscillator is 3, this one. From the right, we have to group it. So we grouped it. The same number is grouped to 2 groups. Now,
Sir,
this.
Sir, second line, second order oscillator 3, how it is there, sir? Please kindly.
3 into 100 minus 1. There are 2 numbers of zeros. So therefore, it is second order.
Okay.
And this is, of course, earlier. Earlier, suppose we had for 31, for 29, 29 it was 3 into 10 minus 1. Okay, so for 21, 3 was my oscillator, but first order, because there is one number of 0. Here it is second order oscillator. And suppose, so this way second order oscillator becomes 3. So we group into 3, and now what do you do? We 55 we multiplied by 3 and then add this one. Immediately see it collapses very fast. The whole thing is such a big number. It divisible by 499 or not. So it is actually second order oscillator of this is 5. So we do by 5 by grouping it, and then this calculation will be big, but it will be nevertheless it will be much easier than that whole division. Collapsing this way, again doing this in this way. You can see it later. 401. It is actually negative oscillator actually. So it is 4 into 100 plus 1. This means that it is a negative oscillator. Plus, sorry, it is plus. So second order negative oscillator is 4. So this one, again we do always minus. Negative oscillator is minus. So this one is this one. For any repeat 9 numbers, 99, 999, always you do that like that. Earlier for 9 we added all these numbers, but here group wise we add, and it becomes divisible, because the oscillator is second order oscillator of this number is 1. Similarly, third order oscillator, because it is 999, it is 1000 minus 1. So first order oscillator of this number is 1, and for 1 we don't have to always multiply 1 by 1. You don't have to proceed. You have just straight away you group them and add them, like in case of 9 we did. We didn't do oscillation method, but we added all the numbers for in case of 9, because it is oscillator 1. So we do not notice that. So procedure was looking different, but actually in the background same procedure is there. So it is 999. So divisible. So whether this big number is divisible by 9999? Yes, because when you group them in 4 and add, it becomes 999, which is divisible. Or it could have been double of that, doesn't matter. So repeat 9 numbers. Or hollow numbers, where there hollow numbers means both sides there will be 1, and in between there will be number of zeros. Name is given to this is hollow numbers. In between there is hollow, but there is 1, both the side there is 1. Whether this big number is divisible by this one, because then we, in case of 11, what we did? Alternate numbers. Here we alternate -1, minus, plus, the grouping with this grouping of 3, because it is 1000 minus 1. So third order is plus 1. Third order oscillator of this number is -1. So -1 means you have to like in case of 11 we did alternate numbers plus minus. So it has to do plus minus, and finally it comes to this. It's just not divisible. Whereas this number, when we did, it becomes 0. That is so this is divisible by, the whole thing is divisible by 1001. About hollow numbers. Multiple oscillator others. By factorization of this one, m into this one, we arrive at a divisibility. Divisibility by 857. So 7 into 857 is 5999. It is third order oscillator, means 6,000. 6 into 1000 minus 1. So 1000 has 3 zeros. So third order oscillator is 6, isn't it? I made a mistake, no? Fix.
गौतम जी 8 बजे हो गया.
Okay, okay. Auxiliary. Why should I write 6? I committed a mistake earlier. Can anybody tell?
Third order oscillatory 6. This is 5,999 plus 1.
Minus 1.
6,000 minus
6,000 minus 1. Now, similarly, all these things, big numbers, 2, 3, 3, 3, suppose you want to get divisibility by 453. We get that this is actually vector of this one. So we get this 1, 2, 3, 4, 5. Fifth order of oscillator, 70,000, whatever it is, and so it is 7. That way you can. Now, on Monday, we will be teaching state division. This is a new topic. Okay, any questions? So, was the revision useful today?
Yes, sir. It is useful, sir. Very useful, sir.
How many?
So, what do we meant to say? These practices you do with make it to understand. Try to make it understand with, say, a student, highly mathematically oriented student of, say, class 6, 7, 8, and so on. I have seen, I did that, and they got very much interested. It's 1 by 19. You start with 1 by 19, 1 by 7 kind of things. They'll be highly interested, I tell you. And you also, in that process, you also become expert on that. In the second level, I think that the symbol of learning will be that you can teach somebody on the first level. Did I tell it correctly, Correct, sir?
Yes, sir.
Yeah. Yes, they should be able to spread the knowledge.
Yes. So 7 level means you are capable of teaching somebody in first level. Or at least the students of, as I told, class 5, 6, 7, 8, highly mathematically interested students, you can start teaching so that
Some people are already doing it.
Oh, yeah.
Sankarai Garu and all, they are teaching their children, grandchildren.
Exactly. Yes.
Thank you, sir. Thank you for taking extra time for.
No, it is all my pleasure actually.
No, sir. Thank you, sir.
Okay, now we'll meet on Monday.
Yeah, we'll meet on Monday.
Okay.
Thank you, sir. Thank you very much, sir. Gautham, sir, thank you very much.
Thank you very much, sir.
Thank you. Welcome.
Ananthan garu.
ॐ स्वस्ति प्रजाभ्यः परिपालयन्तां न्याय्येन मार्गेण महिं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितः ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पौत्रिणः अदनाः सदनाः सन्तु जीवन्तु शरदां शतम् ॐ सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्तिः हरिः ॐ
Dhanyawada. Now let us request Chala Chittibabu garu to sing Janganamana. All of us stand up and sing along with him.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद।
Jai Hind. Thank you. Chala Chittibabu garu.